Welcome students to your favorite channel PRADIP sir classes as PSC, and today we are going to start with another application of dimensional analysis. For the previous class I uh, discuss about what is unit, what is dimensions, what is physics, and what are the different types of physical quantity, and that physical quantity possesses particular dimension. So today we are discussing with another application of dimensional analysis. Dimensional analysis, this is type C, and it is application of dimension. Application of dimension, and the third type is dimensional derivation. That is, we can derive a particular equation with the help of dimensional analysis. So welcome again, and let's start with. And today students, I take some of the easiest equations that you are well known for the previous classes. Suppose students, you know that force equal to MA, or the potential energy equal to mgh, or the kinetic energy, this is half mv square, and we can write as work done equal to force into displacement, that is F dot S. This is dot product, and I discuss what is dot product. It is basically a chapter related vector analysis. So for that chapter I discussed what is dot and what is cross, and what is a vector quantity, what is the scalar quantity. So today's, if your friend say that we can apply a particular equation. Suppose this is F equal to mv, and you know that this particular equation is not correct, and this is actually F equal to mass into acceleration. But if you have no idea about that particular equation, then you can derive the relationship between the force, mass, and acceleration. Okay, so first of all you have to know the different physical quantity and their relative dimension. And so take first equation. So it is F equals to ma. So it is F equals to ma. How can we derive that particular equation? So first of all students, you have to know that force depend upon, the question is that force depend upon mass, and mass, that is m, and acceleration. Force depends upon mass and acceleration. How can you derive a relationship? How can you derive a relationship between this physical quantity. For today's class student, I take so simple equation that you are well known about that equation, and for the next day I discuss in details. For the that equation which are related with NEET, IIT, or main or advanced, for both equations. So first of all, today I discuss easiest numerical relationship. So first of all, we know that we don't know about the equation, so what will be its power? It may be m a square, it may be m square a, or it may be m root over of a. Why this is 1 and this is 1? So first of all, you have write down as f is proportional to mass to the power of x. That is, x is the exponent of mass and force is proportional to acceleration to the power of y. Suppose, let then that is, when this proportionality turns into a equal relationship, then you have to take a proportionality constant, and you can take it as k. What is proportionality constant? I describe it also in the later lecture. So m to the power of x and a to the power of y. So what is the dimension? Then you have to apply here what is the dimension of force, that is ml t minus 2, and this is equal to k m. What is the dimension of mass? That is m to the power of x, and acceleration, that is l t minus 2, and that is to the power of y. So this is to the power of y. So then simplify this one, so m to the power of x and l to the power of y and t to the power of minus 2y. So then that implies that this is, and then you have to compare mass, the exponent of mass, with the left hand side exponent. So here the exponent of mass is 1, so x equal to 1. So we can write x equal to 1. Then L equal to, that is y equal to 1, so y equal to 1. And for the next, you have to compare, just you have to compare the different exponent of the right hand side to the exponent of left hand side. So minus 2y equal to minus 2y equal to minus 2, or we can write here, this is the value, and here is also 1. So the equation, this is the equation. So the equation will be f equal to k and m to the power of 1 and a to the power of 1. So the final equation is ma. You can write ma if you take k equal to 1, and for that particular cases k equal to 1, you have to take 5, you have to take 1, 5 not 2. I discussed also in the later classes. First of all, you have to calculate the relationship between mass and acceleration with force. So the equation, final equation is f equals to ma, and we go through the next example, and you realize all the equations, I think, slowly. Okay. So the next relationship has question number 2. Question number 2, that is you have to derive a relationship between force. Suppose write down the questions. A mass of a body of mass m is revolving around a circular path. So body of mass m is revolving around a circular path with constant velocity. So body of mass small m is revolving around a circular path with a constant velocity. Derive a relationship between a force, mass, velocity, and the radius. we know that when a body of mass m with a particular string, I don't mention here, so mass of m is revolving in a circular path with a constant velocity v. So we discuss all the topic in circular motion, but for that particular session or classes, you have to just only derive the different equations with the help of dimension analysis. So here a force F act along this direction. So force, mass and velocity and radius. R is the radius of the circular path. So all the physical quantity, students, and they are somehow related with each other. And what is the relation? That is the questions. What is the relation? And can you do that particular equations or know that particular equation? But the dimensional analysis knows what is the equations will be. Or dimensional analysis can help you to derive the particular relationship between the different variables. So how can we relate that particular equation? And so you have to just take F is proportional to a quantity and then X. Similarly, F is proportional somehow with the physical quantity, that is velocity, to the power of y, and F is proportional to the radius to the power of z. And then F equal to take a constant value k and m to the power of x, v to the power of y, and r to the power of z. So the equation is F equals to k m to the power of x, v to the power of y, and then put the dimension of force. Force dimension, what is the force? And if you don't know what is dimension and what is the dimension of force, then go to the first lecture and then second, then third, and then this one. So ml t minus 2 is the dimension of this one, and it is a proportionally constant. So m to the power of x, and velocity l t minus 1 to the power of y, and r means it is a distance or length, so l to the power of z. Then students, there is k m to the power of x and l to the power of y, and then t to the power of l to the power of y, and here is also l, so l to the power of, this is the rules of exponents, so l to the power of y, here y and z, so y plus z, and t to the power of minus 1. Then what to do? The second step is, and the next step is you have to compare the exponents of right hand side to the exponents of the left hand side. So x equal to 1, so x equal to 1, and then l, that is y plus z, and this is equal to l, that is 1, and minus y, that is t to the power of, and this is equal to minus 2, this is equal to minus 2. So if we place that is y equal to 2, and if we place the value of y here, then z equal to 1 minus 2, that is minus 1, that is minus 1. Yes, if we place here, that is 1 minus 2, that is minus 1. So x equal to 1. So finally x equal to 1 and y equal to 2 and z equal to minus 1, and then put the equation. So f equal to for that equation you can use so f equal to, what is the relationship? So f equal to a proportionally constant, that m to the power of x, and here x is 1, so m you can simply write down as m, and v for y, that is v square, so v square, and r equal to minus 1, so you can write as denominator. So f equal to k m v square by r, and you can take k equal to 1 and f equal to, the question is that, sir, always we can take the value of k equal to 1, then the answer is no, you cannot, because the value of the proportionality constant, dimensional analysis is fails to calculate that particular value, and that is the demerits of the dimensional analysis. So the equation is this one. Then how we can calculate that particular value, and this is 1, and you can realize what is proportionality constant. And for that particular session, you can consider, you can write down here as it is, don't go for that equation, and then you can get full marks. Okay, so F equal to, if you write the equation and this is the answer, then you can also get a full marks. Okay, so F equal to kmv square by r. K here, K is the proportionality constant, and if you know that particular proportionality constant or given in that particular question, if K, the value of K is given, then you need not go for anxiety, and that is F equal to kmv square by r, or you can write F equal to mv square by r. Okay, so we can then take the next equation. Suppose, students, there is a pendulum, and this is called simple pendulum, and this is the bob, and here the center of gravity, and this is the suspension point. So from here to from the distance between the suspension and the center of gravity, this is called effective length. So it is L, it is denoted as L, and this is from here to the suspension point, L. And the bob, we know that the bob, if we displace slide that is less than 4 degrees, then the bob swing. Okay, so what is the time period? What is the time period of this bob? If you calculate what is the time period of this bob, then you have to derive an equation. That is the relationship between the time period and the mass of the bob. Or suppose what is the relationship between the time period? Suppose with the time period, with derive a relationship between the length that is L of the bob and the mg acts downward, so acceleration also related with that bob. So derive a relation between the length of the bob and acceleration of the bob, that is g. Acceleration due to gravity. Okay, acceleration due to gravity, acceleration of the bob is not correct. So derive a relation between the length of the body, length of the pendulum and the acceleration due to gravity. Okay, acceleration due to gravity. So you have to calculate a relationship or derive a relationship between t length, that is L, and g. And if you want to calculate the relationship between the mass of the bob, then you can take another variable, that is m. But first of all, we have to derive the relationship, that is, we know that t equal to 2 pi root over of L by g, and this is the relationship, and how we can get that particular equation with the help of dimensional derivations or dimensional analysis. So let's start the different steps. So step number 1, you have to take a relationship t is proportional to L to the power of x, and then t are proportional to g to the power of y. Then, and this is equal to a proportionality constant k, and this is L to the power of x and g to the power of y. And t is the time period, so the dimension of left hand side is t, and here m equal to 0, and L is also 0. So this is the dimension of time period, and here you can write the dimension as L equal to x L to the power of x, and g, what is the dimension of g? G LT minus 2. So LT minus 2 to the power of y. Then finally we get L to the power of x and L to the power of, here it is y, so x plus y, and then t to the power of minus 2. So t to the power of minus 2. So then the next step is you have to compare that particular value. Here m is not given, so x plus y, you can compare x plus y with L, that is equal to 0, and minus of 2y, and that is equal to 1 since it is 1. So y equal to 1 divided by 2, that is minus half, and x is also equal to half, since x plus y equal to 0. So x equal to half and y equal to minus half, and then put that particular value in this equation. So step number 3, that is t equal to the proportionality constant and L to the power of x, that is half, and g to the power of y, that is minus half. So k L by g, and half means root. So t equal to k root over of L by g. If you left here, and then you can get full marks. And if you know that particular constant t is 2 pi, then you can write t equal to 2 pi root over of L by g, because the dimensional analysis cannot derive that particular proportionality, that is the proportionality constant. Okay. So this is the final equation, and in such a way we can calculate a different relationship between the different variables. And if we want another example, then we can take another example and write down, pause the video and write down the equations. So students, next we can take another equation, that is we can derive a relationship between the kinetic energy and the velocity and mass. So derive the equation equation between kinetic energy, mass, and velocity. And we know that kinetic energy equal to half mv square. So students, you already know that half mv square, you can derive that particular one, and you cannot derive the value of half this one. That is, you can check the different relationship between the different variables with the dimensional analysis. So kinetic energy, so the first step you have to take, that is kinetic energy is proportional to m to the power of x, and kinetic energy is proportional to v to the power of y. Then dimension of kinetic energy, that is ml square t minus 2. This is similar to work done. So ml square t minus 2. In place of kinetic energy, you have to substitute the dimension of work. Then mass means m to the power of x, and velocity means lt minus 1. So this is equal to y. So k and m to the power of x, l to the power of y, and t to the power of minus y. And then compare the equation. So what are the different steps, students? First of all, you have to proportionalize all the physical quantity, all the variables, and then put the dimension and then compare. So first of all, proportionality, variables, and then put the dimension and then compare. So PDC, you have to know PDC, that is proportionality relationship. Then put the dimension of the physical quantity, both sides, that is right hand side as well as the left hand side, and then compare the exponents of the fundamental quantity, that is x equal to here 1. So x equal to 1, then y equal to 2, then y equal to 2, and then minus y equal to minus 2, that is y equal to 2 again. So kinetic energy equal to proportionality k and then m to the power of x, that is 1, and v to the power of 2. So kmv square, and you know that the value of k is half. So what is the proportionality constant? Dimensional analysis cannot find that proportionality constant, and this is the demerits of the dimensional analysis. But dimensional analysis can check the relationship, what is the exponents relationship between the different physical quantity. So students, continue your study and do some thing and do some derivations of different equation relationship, and then for the next class I will discuss elaborately with different difficult numericals or relationship, or the three types of the dimensional uses of the dimensional equations. That is, the first number one is to check the correctness of the equation, and the next one is how we can change a particular system to another system. So system of units we can change, that is 1 Newton equal to time or to joule, and the different relationship. And the next one is how we can derive a particular equation with the help of dimensional derivations. Okay, so these are all the applications of dimensional analysis, and for the next day we take some different numericals, and all the numericals will be more exciting, more conceptual. Okay, so thank you, and continue, last of all, continue your study. Okay, thank you.